Over Unit 3, Inequalities, Day 2, Graphing the Solution of an Inequality. So here, solving inequalities by multiplying or dividing. Yesterday, remember what we figured out. When you multiply or divide by a negative, we flip the inequality. So we flip the inequality, not the sign, because the sign is negative positive. We don't change that. We flip the inequality. Okay, and then here is the blank of an inequality is the set of all numbers that produce a true statement. And that's our solution. It's kind of like our answer. It's what makes something true. Solution. Okay, when you substitute that variable in, it makes both sides not equal, but one side greater than, less than or greater than, or vice versa. The solution can be shown by making a graph. The solution is shaded. So our answer is what we want to shade on a graph down here. Okay, we're shading for all numbers that the solution can be. Okay, remember closed dot, we want to include the point. So we want to include the number that the circle is on. So we'll shade it in. And that's if it's less than or equal to or greater than or equal to. And down here, open dot, we don't want to include that point. So it cannot be equal to. It has to be numbers less than or it has to be numbers greater than and not equal to. Okay, so right here, we're just going to read x is less than 3. This represents we are shading all numbers less than 3. So there's no numbers. We're just going to start. I like to put the number that I'm working with right in the middle because I can. If you don't like to do that, if you want to go 0, 1, 2, 3, go for it. And then let's put 0 and 6. So I go 3 one way, 3 the other. Okay, we are not actually including 3 here. It's just x is less than. So we're going to be open. And we want to shade any number that's less than 3. So I'd like you to pick a number that's less than 3. Okay, maybe you said 1, maybe you said 0, maybe you said a negative number. So either way, it's this direction. So you can shade this way, or you might like to draw it this way. And I think you all have a preference, and you go at that preference. Okay, so y is greater than 2. So we want to shade all numbers, all numbers greater than 2. So again, you might put 0, 1, 2. I don't care. I just am so used to doing it this way. 0 and 4. So are we open or are we closed? Do we want to include 2? Is 2 greater than 2? No, it is not. So we're going to be open on 2 because 2 would not make this true. And then numbers that are greater than, pick a number that's greater. Maybe you said 4, maybe you said 1,000, maybe you said 1,000,000. Either way, it is to the right. And maybe you go this, it doesn't matter. Okay, z is greater than or equal to 4. That's all numbers greater than or equal to 4. So let's mark 4. That's the number we want to focus on. And are we open or closed on 4? Are we including 4? Like, would that make sense? Is 4 greater than or equal to 4? Yeah, it's equal to. So we want to close that because we're including it. Now we want all numbers greater than. And think of a number that's bigger. Let's go 5. Maybe you went 10. And we know that that would be over here. So 3, 4, 5 would be this way. You do not have to do both of those arrows. Just choose one. Right? And then n is less than or equal to 2. So we want to shade all numbers less than and equal to. So we're going to put 2. And does 2 work here? Does this make sense? 2 is less than or equal to 2? Yep, it's equal to. We want to include it. And then pick a number that is less than. And you probably figured it is this direction. Maybe you chose 0. Maybe you chose a negative number. But there you go. That's how we do it. So let's practice back here. Now this is a kind of a little review from yesterday. We're going to solve these 2 steps. Box your variable, subtract 5, subtract 5. I'd like you to pause the video and do this on your own and then see how you did. 3x is greater than -9, same sign sum, and my -5 is bigger. And then I'm going to divide by 3. And every time I divide, did I just divide by a negative? I did not. So I'm not flipping that inequality. X is greater than negative 3. Okay, so we want to shade all numbers greater than 3. Okay, can this be equal to? No. So negative 3 is open because it is not equal. And make sure I recognize that 0 is to the right. And I'm going to put a positive 3 there. So we want numbers greater than. Is 3 greater than negative 3? Yes, it is. So we're going to shade this way. And solutions. Negative 10 would not be a solution. It's going to be down here. Negative 4 would not be a solution. 3 is not a solution because it's not included. It's not closed. So 3 is not a solution. These 0, 3, and 10, all numbers in this direction are solutions though. Okay, we've got another 2-step. Box that variable term. Add 3, add 3. Okay, I see we have different signs now. So we have negative 4 plus 3, different signs. So we're going to subtract. And my negative is bigger. So we are negative 1 there. Okay, and my variable right here, we've got x divided by 5. And the opposite is multiplying. So we're dividing. We're going to multiply. Again, we did not multiply by a negative. So we're not flipping that inequality. And here we go. X is greater than or equal to negative 5. So I'm going to locate negative 5, 0, and 5. I think with negatives, that's a really great thing to do. Recognize the positive and the negative. And since we're equal to, we're going to be closed on negative 5. Okay. And we want all numbers greater than. So any number, pick a number that is greater than negative 5. Yeah, 5, 0, 1,000, whatever you chose. Okay, negative 10 is over here. It is not a solution. It is not shaded. Yes, negative 5 is a solution, and these are all numbers in this direction. So all of these numbers are solutions. Okay, so here we just have a 1-step. So if I box that whole variable term, there's nothing left. So I just need to separate negative 3 and x. And now they're not subtracting. This does not say 3 minus x or x minus 3. It's negative 3 times x. So we want to divide. Divide by negative 3. Oh, and we're dividing by a negative. Remember when we divide by a negative, we have to flip this inequality. So it's going to go from less than to greater than and equal to. My x is left alone. And pay attention, when we do this, we've got our triangle. 2 negatives makes a positive, but I've got a negative and a positive, so my answer has to be a negative. Okay. So I'm going to go negative 4, 0, and 4. And I want to shade all numbers greater than. So pick a number that's greater than negative 4. Maybe you say 0, maybe you say negative 3, maybe you say 4, or maybe you say 1 million. Oops, sorry, we are closed. But either way, it's this direction. Okay, negative 5 is not a solution. It would be right there. Negative 4 is a solution, and then all numbers above this are all solutions. All right, so another 1-step. Right now, this is x divided by negative 5. So we're going to multiply by negative 5. We're going to multiply by a negative. Multiply by a negative. If we multiply by a negative, we flip our inequality. So x is less than or equal to. Okay, let's do this. Am I on the screen here? All right, let's go 5 times 1.3. 5 times 3 is 15. 5 and 6. Move my decimal once, move my decimal once. So 6.5 and a positive divided by a negative. My answer has to be a negative. Right, so we're dealing with negative 6.5. We're just going to treat this like a number. And 0, and we'll say this is 6.5, positive 6.5. Right, so since it's equal to, we're closed on this dot. And we want all numbers that are less than. So pick one of these. Is 0 less than this? And maybe we're like, well, I'm not really sure. Well, is 6, like $6.50 less than negative $6.50? No, it's not less, so we want to go less than to the left. It's this direction. Okay? And as far as solutions, negative 12. Yes, negative 12 would be over here. It is a solution. Negative 7. Yes, negative 7 would be right about there. Negative 6. Oh, -6 would actually probably be somewhere in here. So no, it is not. And then -1, none of these other ones would be. All right. And here we go, our last two. I'm going to box the variable term. Make sure you include that negative. And right here, it's not multiplying. This reads 7 minus 2x. But you've got to think about the sign in front of this. Like, what's the opposite of this? That's a positive. So we're going to subtract 7, subtract 7. Okay, we're not multiplying or dividing by a negative yet, so we're not doing that. And a lot of you notice you like to look at the term and you say, well, that's negative, so I know I'm going to be flipping it. But make sure you only do it once. Okay, and let's divide by a -2. Divide by a -2, so we're dividing by a negative. So we flip that inequality. X is greater than -1. So let's go -1, 0, 1. Sorry, -1. Open on -1 because it is not equal to, and pick a number that is greater than -1, and it is to this direction. Nope, -8 is not a solution. -2, not a solution. It's not shaded. -1 is not a solution because it's not shaded. Meaning -1 is not greater than -1. I can't fit it in, and that's not true. 0 is a solution, yes. 1 is a solution, 2 and 8, they'd all be solutions. And my very last one, here we go. I'm going to box this variable term. I'm going to include this negative and not the positive. I don't need both. I can never exclude a negative, but I can exclude a positive in this case. So we've got -5 plus x divided by -2. Right here it says a -5, and it's just being added and subtracted, so we want to add it, do the opposite. So I'll add. Okay, please pay attention to your different signs. They differ. And my negative is bigger, so we've got -2. And then I'm going to drop this. Okay, so we've got x. I want to get x alone. X divided by -2, so I'm going to multiply a -2. I'm going to multiply a -2. And x, I'm going to repeat it just like this. -2 times -2 is +4. So I've got 4, 0, and -4. And we are equal there. So we include it. And x is, so 4 is less than or equal to x. Now this is different because 4 is less than x, but we're not shading for 4. I mean, we did shade for 4, but we want to shade for x. So you have two different things. You can rewrite this and flip your inequality, or you can read it backwards. So we'll start by reading it backwards. X is greater than or equal to 4. So we know we want to shade numbers greater than. Or you can rewrite it. If I flip x and 4, then I have to flip my inequality. Now x is greater than or equal to 4. So we would shade this direction. -8 is not a solution. It is not shaded. -4 is not a solution. No, 0 is not a solution. No, 3 is not a solution. Yes, 4 and 8 would both be solutions. Okay, here we go. So, got two-step equation, box that variable term, add 2, add 2. 3/5 x, 3, no negatives there. Okay, so right now, we read this 3/5 times x. Oliver, turn that down, please. Okay, we're multiplying a fraction. So we would divide. We don't divide fractions, we multiply by the reciprocal, right? So let's multiply the other side by the reciprocal as well. If I'm going to multiply this side, I have to do this side as well. So we put that over 1. Those cancel. And I am not multiplying or dividing by a negative. So I've got x is greater than. Let's multiply straight across. 3 times 5. Actually, you can cross produce, right? And put those both 1s. And then you'll get 5. Or you can say 3 times 5 is 15. 1 times 3 is 3. And 15 divided by 3 is 5. So now my answer, x is greater than 5. Let's put 5, 0, and -5. Okay, we want all numbers greater than 5. We are not equal, though. So that is greater. -15, no, that's not a solution. -5, no. 0, no. 5 is not even a solution because it's not shaded, but 15 is a solution. Now down here, we're given the graph and we have to write the equation. So we're going to write x and the number where that circle is, -2. We're going to write x and the number where that circle is, -2. We're going to write x and we're going to write 4. Okay. If you have your own way and you do it and you love it, stick with it, go for it. Great. I'll show your answer written both ways. So now, is it equal to or not equal to? And since it's shaded, yes, 2 is included, so it's going to be an equal to. And are these numbers less than or greater than -2? Well, we're going more negative, that makes them less than. So x is less than. And maybe you say, this is x. Well, that's less than. So x is less than -2. Okay, if you wrote it the other way, it should be this. No matter what, you were eating the -2. You were eating the -2 and pointing to x. Okay, -25, yes, that's a solution. -5, yes. -2, yes. None of these are. They're not shaded. Okay, right here, since this is open, that is not included. That means it's not going to have that equal to sign. It's just going to be either greater than or less than. And I'd like you to say that this number right there is an x, 2. Is 2 greater than or is 2 less than? 2 is greater than. X is less than in this case. Now, if you wrote it backwards, it would be -2 is less than x. Either way, you're eating the x, pointing to -2. And let's see. -9, no, not a solution. -3, no, it is not a solution. -2 is not a solution. The rest of them are. Everything else is shaded. Okay? And let's see. We are not including that 4, so it's not going to be an equals to. And I'd like you to pretend like any of these numbers that are shaded are x. 7 and 4. Which one does the alligator want to eat? 7 or 4? 7. Okay, and if you wrote it this way, it's 4 is less than x. -4, no, there's no negative numbers included in this at all. 2 is not included. 0 is not included. Yes, 4, 9, 12, 29, all of these numbers are included.